Hi, I'm Jeff Wimmett, and I'm an applications engineer here at Altera. Today I'd like to share with you some FPGA-based solutions that can aid in the development of systems requiring industrial Ethernet protocols. These are the type of protocols you typically find in factory and process automation systems. Now, by using an FPGA in your industrial Ethernet system, you can get the performance and interoperability you want, along with the platform flexibility and obsolescence protection you need to stay a step ahead of the competition. Here at Altera, we've partnered up with several different industrial Ethernet solution providers, so we can actually offer support for any of the open standard industrial Ethernet protocols that are out there. These protocols are all based on the same IEEE standard, so you can actually use a single FPGA-based platform to develop for, or interface to, the protocol of your choice. Some of these protocols demand high-speed, real-time performance. For those, the real-time functionality is implemented in hardware as a protocol-specific MAC, while the rest of the functionality is handled by a software stack running on a processor that's embedded within the FPGA. Like, for example, Altera's Neos 2 soft core processor running on a Cyclone 3 FPGA. That also happens to be the way that most of the demos I'll show you today are built. Let's take a look at a couple of them in action, shall we? In our first two demos, we'll show the Profinet and EtherCAT solutions from Softing. These demos actually integrate both motor control and industrial Ethernet into a single Cyclone 3 FPGA. That's very neat, but what we're highlighting today is just the industrial Ethernet functionality. So here's the setup. First, we have Softing's Ethernet module. That's connected to a PC, which will allow us to configure the FPGA with a design that contains that industrial Ethernet-specific MAC and the Neos 2 processor that's running the protocol-specific software stack. Secondly, we have a Profinet PLC, or Programmable Logic Controller. That will act as the master and actually send commands encoded in the Profinet protocol about how our motor should turn. The protocol-specific MAC within the FPGA will then interpret those commands and pass them to our motor controller board, which is the third piece here, our UNIO motor control board, connected to a brushless DC motor. The UNIO board will actually turn that motor based on the commands the PLC generates, the Ethernet module receives, interprets, and passes on to it. And if our Profinet communication goes right, then we should see that motor begin to turn. The first step is to download to the PLC the program that will turn the motor. So first off, we'll use the Step 7 software here to download our motor control program to the Siemens PLC so that it knows what Profinet encoded commands to send to our Ethernet module. We'll select the PLC and Download menu, and then we'll delete the current system data within the PLC and override it with our motor control program. And now the PLC is configured with our motor control program. The next step is to configure our FPGA with the Profinet-specific MAC and the Neos 2 processor that will run our software stack. So to do that, we'll use the Quartus 2 programmer. And we've got our soft file selected here. We'll push Start. And we'll configure the Cyclone 3 device that's on the board. Now, the Profinet MAC runs in the Open Core Plus fashion here. We'll leave that up and running, and we'll switch over to the Neos 2 IDE. From here, we'll select Run, and we're going to run a Neos 2 multiprocessor collection called the Profinet demo. We'll select Run and download our software program to the FPGA. And we're downloading. And now we've successfully downloaded the software program to our Neos 2 processor. The final step is to turn our PLC into Run so that it begins sending the Profinet encoded commands. Push that to run, and as you can see, our motor begins spinning, meaning that we're successfully communicating through the Profinet protocol from our PLC to our FPGA. All right, secondly here we're going to look at an EtherCAT protocol. What we're going to do is we're going to disconnect the Profinet PLC, or Siemens PLC, for the Profinet protocol, and we're going to wire up a Beckhoff PLC that'll communicate in the EtherCAT protocol. We just plug that into our industrial Ethernet module. Now, the Beckhoff box actually retains its configuration, so it's already configured with our motor control programming. meaning that all we need to do is configure our FPGA with the EtherCAT specific MAC and the Nios 2 design. Push the start button in the Cortex 2 programmer to download the soft file. And once again, we're running that EtherCAT MAC in an OpenCore Plus fashion. Now we'll switch to the Nios 2 IDE, and we'll run our EtherCAT demo. So we're downloading the software program to that Nios 2 processor that's running on the industrial Ethernet module. And we've successfully done that. So now our motor should start turning. And there it goes. As you can see, we've got a successful EtherCAT communication going on between the Beckhoff box and our industrial Ethernet module. So it's pretty simple to reconfigure the FPGA on this little industrial Ethernet module here so that it can communicate with either EtherCAT or Profinet-based PLCs. Now these two demonstrations are both courtesy of our partner, Softing. And Softing sells this industrial Ethernet module here as a standalone unit, so you can just integrate it into your existing system, thus enabling it to handle communications with any protocol you want. Or, if you want to integrate the industrial Ethernet solution into a new design, Softing actually provides the Profinet and EtherCAT MACs as IP cores, which you can license and then use to implement a more comprehensive solution all within the same FPGA. In addition to Profinet and EtherCAT solutions like the ones we just saw, Softing also has stacks available for Modbus TCP and Ethernet IP. Now let's take a look at another demo, this one from our partner, Ixet. Here we'll go through how you can use Ixet's industrial Ethernet module to support the PowerLink protocol. Now this demo consists of a PCI-based card that's in this machine here. And that's essentially going to act as our PowerLink master. And it's connected through this Ethernet cable here to Ixet's industrial Ethernet module here. Now that board is wired to this larger base board here that's emulating a piece of factory automation equipment. And we'll be able to verify that we are actually communicating through PowerLink by seeing the LEDs on this board light up, showing that we've got a successful communication via the PowerLink protocol. Now the configuration for the FPGA is actually stored on the industrial Ethernet module as within this flash memory. So when we power up the board, the configuration is automatically loaded into the Cyclone 3 device. So we've already got the Nios 2 processor and the appropriate MAC loaded in there. All we have to do is launch our test application over here on the PC. This will allow us to communicate to the PCI card. We'll initialize the firmware. We should see some checks come back okay here. Here they come. And our firmware is initialized. Now we'll download the CDC file here. Now we're just waiting for the communication link to be established between our PCI card that's acting as the PowerLink master and the industrial Ethernet module. See, initialization is successful. And now we're operational. So we select Poll, and we're actually able to touch on an LED here and see the corresponding LED light on our board that's emulating a piece of factory automation equipment, as well as on the representative LED here. So we'll touch another one here. And again, it lights on the board and in the GUI. That's showing that we have established successful communication via the PowerLink protocol. Now, again, the idea here is that you can easily add industrial Ethernet communication to an existing piece of your equipment just by adding this industrial Ethernet module to your system and wiring it up to the host processor that's already controlling your equipment. That means you don't have to rewrite the control software, but you can still pull information from that piece of equipment through the industrial Ethernet protocol of your choice. Now, Ixet provides this industrial Ethernet module for sale. They also provide their solutions as IP cores, so you can license those and use them to implement a more comprehensive solution within an FPGA. Through these demos, you've seen how an FPGA can support any industrial Ethernet protocol, and how quickly and easily you can change the protocols within the same FPGA-based platform.